Welcome everyone. Today we introduce Approaching the Real World, Supporting Activity Recognition Training with Virtual IMU Data. My name is Hyuk Kwon, and this work is done with Bing Yao, Dr. Gregory Abad, Dr. Thomas Plotz from Georgia Tech Ubicomp CBA Lab and Northeastern University. Last year, we proposed IMU tube system, which is a grand vision for creating significantly large label dataset for wearables by using video data to generate large virtual IMU dataset. In this work, we extend the IMU tube with adaptive video selection to generate high-quality large label dataset, which could improve deep learning models significantly, 0.5 to 0.75, for challenging hard problem, the weightlifting. Mainly in IMU tube, motion information from the video is extracted with 3D motion tracking, which is again converted to virtual sensors on on-body locations. To collect high-quality virtual sensor data, high-quality 3D motion tracking is essential. However, there are a lot of challenges in unconstrained online videos, fast motions, complex camera movements, and occlusions. To make IMU tube usable for real-world videos, to generate high-quality large virtual IMU dataset, we propose to handle such challenges in online video for motion tracking. In doing so, we propose adaptive video selection. The extended IMU tube, given a video, detects artifacts in the video segments, such as extreme background motions or uncertain pose detection, and remove those noisy frames to prevent error accumulation in motion tracking, and generate high-quality virtual IMU data from the remainder of the video to train the model. Specifically, we handle 4 different kinds of challenges. Non-human objects from the confusions of pose detector are handled with noise pose filtering. Various occlusions, such as self-occlusions and occlusion by people or objects, are handled with occlusion handling. Motion blur, which can generate spurious poses from fast human motion, are handled with foreground motion detection. And excessive motion blur from extreme camera motions are detected with background motion detection. To evaluate the effectiveness of extended IMU tube, we experimented with free weight exercise classification. Specifically, we classified 13 dumbbell activities. As you see in the 6 examples, dumbbell exercises are very subtle in differences in arm motions and poses that challenging in classification. In our experiment, we used 3 different benchmark datasets, but in this video, we show results for MyOGym dataset, which had 3.5 minutes of sensor recording per activity with single wrist sensor, and where activities are performed in the lab with control. For virtual IMU dataset, we collected videos from YouTube where activities are performed in the wild at various occasions. And 100 times larger size of virtual IMU data was collected compared to real IMU dataset, which goes up to 3.2 hours per activity with weekly labels, where searching keywords are used as target ground truth labels. With this large-scale virtual IMU dataset, we show that we can significantly improve deep learning performance. Here's the experiment result. In this experiment with MyOGym dataset, we show how changing virtual IMU data size can impact model performance. We start with real IMU data only, 3.5 minutes, and we eventually add up to 3.2 hours per activity, which is 100 times larger. As a baseline, we evaluated on random forest with ECDF model. And you can see that as we add virtual IMU data, the classical machine learning model can consistently benefit from more data set. But when we use deep learning model, the improvement is substantial. Data and hungry nature of deconvolutional model, which is standard and very popular deep learning model in R, can largely benefit from large-scale dataset, which is 0.23 F1 score. And this shows that to train a complex model, you have to collect more videos. And extended IMU tube can collect high-quality, large-scale label dataset, and that can train deep learning models. More extensive experiments and analyses are in the paper. In summary, we extended IMU tube with adaptive video selection to generate high-quality large virtual IMU dataset. In doing so, we are now ready to collect large-scale data beyond a single wrist sensor and with multiple on-body locations for complex deep learning models. And with large-scale virtual IMU dataset, this is the right time to design very sophisticated large hard models to drive breakthroughs in hard. And please download virtual IMU dataset today and have fun. Thank you very much.